Okay, guys, this is a video I would probably title FYI. There's, other than the first couple of minutes where I point out something in terms of cleansing your data, it's not something you're going to be tested on. This is for those of you that, I notice when I talk to students and kind of watch the way people approach their classes, and this is very natural consequences that some of you just have found that this statistics stuff kind of tugs at the heart, and it's something you really like. While others of you are just like, it's something I have to take to get my degree or get my 18 hours. Sign me up, and I'm going to forget it as quickly as I can after everything's done. And I understand that. I took classes in my graduate coursework, some that I enjoyed more than others. So really, other than just the first couple of minutes where I talk about cleansing and coding the data and setting up the spreadsheet correctly, this is more for those of you who just kind of find this stuff kind of interesting. The data set that I have here, I've titled it random because these numbers really don't mean anything. I just created 4 measurements in 3 groups. So if I wanted to run an ANOVA or run a regression, I would need to set up my data set correctly. So keeping in mind what I talked about in the previous video, or at least one of the videos where I explained what I wanted on assignment number 1, it's important to get the data set set up correctly. So I'm going to work with variables, and as I look at this data set, I see that I have some scores. Don't know what they mean. Well, they don't mean anything. And the next thing I would put is group. I have 3 groups, A, B, and C. So the scores, I would copy and paste those under scores. And then I would come into my groups, and I'm just going to type this in. Typically I would copy and paste this or fill down, but this is small, and it was meant to be. All right, gang, this information, I need to get rid of that because I don't want that getting into R and confusing things. And I'm just going to come up here and do a save as. And I'm going to continue to call it random, but I'm going to save it as a CSV. All right, so I'm going to hit cancel. I'm sorry. I want to hit save, and I want to continue. And then I'm going to close this down because I don't need it anymore. Guys, no need to save it because we already saved it. So on our desktop, we can see that we have a CSV file called random. Now what I need to do now is get this information into R. So the first thing I have to do is set my working directory. And then I need to read my data. Now I'm just going to call it data. And we should be really, really good at this by now. And we need to attach our data. And, most people like to see it. And if that's the kind of stuff that you need to do, then go ahead. Now, first thing I want to do is if I were going to run an ANOVA, I would probably want to look at the group means. So I would do that by T apply, use scores over group, and report the means. So you can see the mean for group A and B and C are given as 4.75 and so on and so forth. Now, what I want to point out now is how ANOVA and regression are actually, in many ways, doing the same thing. And this goes back to what we call the general linear model, which is this overarching model that kind of oversees both processes of ANOVA and regression. And a general linear model is just really the sum of 2 parts. It's the part that our model can explain, and it's the part that's unexplained that we call our error. And our total prediction, if you will, is a sum of those 2 parts. Now, something kind of cool happens when I run a regression. and I'm just going to call this linear. So if I run a linear model where I'm trying to predict scores from group. Now guys, let's think about this. This gets into what we call dummy variables. And the way that R will create dummy variables is it'll look at the first group that we give, and it'll give that as the reference group. So our linear model is going to consist of two coefficients, well, three including the intercept. Now, if you look at group B, this coefficient right here, the negative 3.0, would just tell us that when we're comparing to group, how the comparison would be from group B to group A, and this group C would be the comparison of group C to group A. So again, this is a little bit of review on dummy variables. When we have a categorical predictor in a regression model, we choose a reference comparison group, and then we can create k-1 coefficients from there. But what I want to point out here is notice that the group means, which would be really important if we were running an ANOVA, show up in a tricky format, in a sense, for the coefficients of our model. Notice that the intercept of our model is just the mean of the reference group, and notice the coefficients of group B is just the mean difference. So if I take B minus A, 1.75 minus 4.75, I get negative 3. If I take 6.25 minus 4.75, I get 1.5. Now, just to demonstrate this a little further, if I do summary of my linear model, this thing will actually calculate p-values, but it'll also give me an F statistic on the overall regression model, if you think from the ANOVA perspective. Now, if I were going to run an ANOVA, and I'm just going to call this ANOVA, I would do AOV, and I would do scores across group. And if I do my ANOVA model, you'll see, well, no, I don't need to do that. I need to do summary ANOVA. You'll see that the 4.96 F value from the ANOVA comparing group means is exactly the F statistic that we got from the regression model, which is actually predicting the scores from the groups in which they fell. So guys, it's not really an aha moment, but then it is a little bit. The intent here is just to show you that regression and ANOVA are very similar statistical techniques. One seeks to explain relationships, that would be ANOVA, and the other seeks to predict relationships or predict values. And that, of course, is the regression. So that's all I got here. The next video that'll be put up will be one on marginal mean plots. That's an extremely important video that I want you to watch through at least once and watch very thoroughly. And then your next video for this week that'll be put up will be a complete, very thorough illustration of two-way ANOVA. So guys, that's all I got. Take care.